today I'll be finding a formula that can tell you the, oh, that's a bad line, but whatever. That can tell you the length of a line from a certain point to another point with only the function itself and the knowledge of an integral. So a formula that can calculate this length of the line, and it's completely erratic, and it's given by this formula. So first thing we need to do is we need to split this thing up into multiple pieces. So like if you know how to, how integrals are derived, it should be familiar to you. And let's take this little piece right here. So it looks something like that. All right. And let's call this distance h. All right. That means this height right here, is the base, which is h. This height right here would be f of h. All right. And let's further take into account this little triangle up here. So if we zoom in into this triangle, we get this. And well, we know this is h from here. But what is this distance? Well, this distance will just be, let me think. Okay, so distance from here is f of 0. Here's f of 0. Hopefully that's intuitive, why this is f of 0 and this is f of h. And as you can see, f of h minus f of 0 is the height of this triangle. The height of this triangle is f of h minus f of 0. All right? And now, this part is the distance we want to find. This is the thing that's part of this line here. So, well, obviously from Pythagorean's theorem, you know that the length of this line right here would be h squared plus fh minus f of 0 squared from Pythagorean's theorem. So that's the length of this side right here and what we're trying to find. All right, so now we have a general formula. So as you can see here, let me just do the next triangle for you. Let's try this thing. So that looks bad. All right. See, it looks pretty similar to the first one. So basically, this will have a height of f of 2h. This will have a height of f of h from here. We're considering this thing right now. So that's f of h. This is f of 2h. All right. And this will have another base of h. And as you can see here from the same logic, this will end up having this length right here, or this length right here, will end up having a length of, just h squared. Yeah, whoops, my bad. H squared plus f of 2h minus f of h squared. All right. Hopefully you're able to understand this. All right, so now that we split this line into multiple pieces, we need to sum all those pieces together. So you can see the general way how these will progress. So it would be something like h squared plus f of h minus f of 0 squared plus h squared plus f of 2h minus f of h squared plus h squared plus f of 3h minus f of 2h squared, and so on. But for now, let's just take into account this formula, this piece right here, and let's try to simplify it. So we're looking at this one thing right here, right? So it would be, let's distribute this. Or let's multiply it together with itself and expand it. So it would be f of h squared minus 2 f of h, f of 0 plus f of 0 squared, all within the root, right? And let me split this up into 2. So we get this, h squared plus f of h squared minus f of h f of 0 plus f of 0 squared minus f of h f of 0. All right? So you see what I did here? I split this thing into two. All right? And let's factor f of h and f of 0. So we get something like this. H squared plus f of h. Within this parentheses is f of h minus f of 0. Plus f of 0. F of 0 minus f of h. All right. And here's where I show you something different. Let's go on a tangent, if you will, and let's review the definition of an integral, or a definition of a derivative. So what is the derivative of f prime? Wait, let me think. F prime of 0. Think for a moment, and I'll tell you the answer. It would be f of h minus f of 0 as h approaches 0. H approaches 0, right? And then something you can notice here is, or actually, yeah. So something you can notice here is this top part looks like this, and it also looks like that. And what we can do here is multiply h on top and bottom to this formula right here. So what we do is we multiply h on the bottom of this, and then we multiply h here, and we get the same answer because the h's cancel out. And we multiply h here, and we multiply h here. Denominator, numerator, they cancel out, and so we can do this. And then, as you can see here, this would become positive f prime of 0, and this would be negative f prime of 0. So let's see what we get. Right, this is what we get, and we're almost running out of space here. But now I want to factor out f prime of 0 and h, and here's what we get. And again, you probably are going to expect what I do next. I'm going to do something very similar. Remember, this thing looks like that. All I need to do is multiply an h on the bottom and an h on top, right? So, all right, I'm going to multiply an h on the top and an h on the bottom. And we get this, h squared plus h squared f prime of 0. And this just simplifies down to all right, we factor out h, we get this. All right. Now, we can do the same amount of steps, and we get that this just translates down to, all right. So, yeah, if we can do the same thing for this, and we get a similar answer. So here's how it'll look like. And so on. All right? So that's how it looked like. So we simplified this down to that. All right, now we need to review, or my definition of integral. Here's my definition of an integral. So let's say we have some function g of x, right? And we just want to find the area of the curve. So we split this up into multiple rectangles. And so the integral of g of x from some 0 to x would be the base times the height of the first rectangle, or h times f of h, because this is f of h, plus the base, or another h, times the height, or f of 2h, plus h, f of 3h, and so on. Alright? Hopefully you can understand that. So yeah, this is basically what an integral is. But as we can look here, let's just set some h of x equal to 1 plus f prime of 0 squared. And we can okay, never mind. Yeah, I don't never mind. But basically, from this definition of an integral, we can get that this sum here would be an integral from, well, 0 to some x. X is a stopping value, so x would be here, x, so 0 to x, stopping value, and we can remove the h, we get this. D of x, alright? And the normal form, if we do not consider, or I don't know what you call it, but without specific limits, it would be this. And that's how you find the length of a, so this is how you find the length of a graph, or I don't know what you call it, like if this, the length of this line here, the length of a line given by a function. This is the formula for it. Hopefully you know how I got from here to an integral, because we can treat this thing as a function. So if we can treat this as a function, and it looks pretty similar to this. So this is, if this is an integral, then this must be an integral too. But that's, yeah. So this is the proof. And that's it. Thank you.